a coding tutorial that shows you how to interact with DeFi applications, how you can use cryptocurrency, how you can earn yield inside of an application. Okay, so we've been doing several DeFi videos in this program because hey, it's such a hot topic right now. It's one of the major use cases for blockchain technology. Ethereum in particular is at the core of the DeFi ecosystem, as the epicenter of all the DeFi activity and innovation that's happening in the blockchain space. And that's what's really important for you to know about. If you're trying to build your own application, hey, this is what users are actually doing. If you're trying to get a job, or as a freelancer, then of course these are the hot in-demand skills that people are hiring for. I hire for projects myself, and trust me, it's challenging to find people who are qualified who understand this type of stuff. So that's why I make this video for you today. So let's talk about what we're going to cover. We're going to cover MakerDao. So MakerDao is a DeFi application that governs the DAI cryptocurrency. Okay, so what is DAI? I'll pull up my screen here. All right, so DAI is a stable cryptocurrency whose price doesn't change. Right, that's this major use case. So you can see cryptocurrencies like Bitcoin or Ethereum, for example, or Ether, I should say. The price goes up and down like crazy. That's what we call volatility. All right, cryptocurrency is very volatile by nature. It's a very new asset. New assets tend to trade that way or tend to be volatile in price. So DAI solves this problem. It's a cryptocurrency whose price doesn't change. Okay, so it's pegged to the US dollar. You can see the dollar value here, about $1 US. Okay, the price has some volatility, but very, very slight and imperceptible for most people. Right, on a small amount of money, roughly a 1 to 2% swing here is not that big of a deal. Right, especially if you're able to most of the time redeem it for $1. So how does DAI work? Well, it's actually a decentralized stablecoin. So you might see some stablecoins like USDC, for example. So I'll just pull up my chart here so you can see it. USDC, like USDC coin, is also a stable cryptocurrency whose price doesn't change, but it's a fiat-backed stablecurrency. So it's actually an organization that will always let you redeem 1 USDC for 1 DAI. There is some centralization to this. It's fiat-backed in the sense that it's backed by actual money, all right, not cryptocurrencies. So that's a key distinction from DAI. It's a decentralized stablecoin. There's no dollars backing up the value. It's actually other cryptocurrencies, okay? So when DAI first hit the scene, you're able to create new DAI and back it with Ether. And that's exactly what I'm trying to do in this tutorial. I'm actually going to interact with the MakerDao smart contracts with code so that you can actually create new DAI with cryptocurrency, okay? That's what MakerDao does. That's what DAI is. That's how DAI functions in the ecosystem so that you can be inside a decentralized world and actually have, a cryptocurrency price doesn't change. So the last thing I mentioned about DAI here is it is an Ethereum token, so it's an ERC20 token. What does that mean and why is it important? Well, basically, an ERC20 token is a cryptocurrency that's powered by smart contracts. So that's one of the cool things about Ethereum is it lets you create your own cryptocurrency without creating your own blockchain. Basically, you can just create a smart contract with code, a programmer can write it, put it on the network, and then you have a brand new cryptocurrency that you can program. That you don't have to actually go through the hassle of actually creating a new blockchain from scratch and convincing a bunch of people to run that network. That's really hard to do. So that's cool about Ethereum. Anybody can create cryptocurrency, go get put it on the network, and that's what DAI is. It's an ERC20 token with a lot more advanced features than most ERC20 tokens. And I'm going to show you how to create DAI with MakerDao DeFi smart contracts in this video. All right, so let's talk about how you actually mint DAI. So what's the high-level process of doing this? Well, you interact with MakerDao. Okay, so MakerDao. MakerDao is a set of smart contracts. It's a DeFi app, right? And also Maker, I want to emphasize this. Maker is one of the original DeFi projects. Okay, it was super early in the space, super innovative. And yeah, that's another reason that's so important. DAI has become a really important cryptocurrency with really strong network effects. And that's another important that they were early, right? And it's become a staple in the industry. And that's one reason I want to make this video to show you how it works. So I went on a tangent there for a second, but let me just talk about this. So MakerDao is the app that governs DAI and lets you create DAI. So what happens is, let's just put DAI here. If you want to create DAI, what you do is you go to MakerDao and you supply cryptocurrency like Ether. Okay, you take Ether and then you mint DAI through MakerDao and you actually create new DAI, right? So this is how DAI actually has backing. So anytime you have a stablecoin, you have to understand there has to be a place where people can go redeem the stablecoins back to $1. So this happens on exchanges for sure. But how do you prove that a stablecoin has a peg? How do you prove that it has some sort of value that actually can prove that it's $1? Well, it's because it has to have some other value backing it up. I talked about USDC earlier, which is a fiat-backed stablecourrency. So it's actually fiat currencies that are backing up that value. Well, MakerDao is a decentralized stablecoin, so it actually has other cryptocurrencies backing its value. So one of the reasons it's really important to understand is this makes DAI censorship resistant. It's a decentralized stablecoin. There's no be very, very, very challenging to just shut DAI down. Like it's really hard to shut the Ethereum network down because there's nodes spread across the entire world. There's no one jurisdiction where you can access each node to make sure for DAI on the network. There's no one country that has a controlling interest in DAI, so it's censorship resistant. And in a decentralized way, other people, individuals across the world have supplied cryptocurrency to this MakerDao application here to mint DAI. So that if you were able to participate in that process, it's totally decentralized in this way. You can just take your Ether, supply Ether to MakerDao, and then create new DAI based on this. So basically use your ETH as collateral, and then basically a little bit less than your Ether value is the amount of DAI that you can create for doing this. Okay. So of course you can go to the MakerDao website and do this all directly through the interface, but I'm going to show you how to do it in code today as a developer. So this will show you how to create your own applications that will interact with Maker contracts. That's one benefit. Another benefit is you just see how the nuts and bolts of these applications actually work. So if you're going to be a developer, you'll get a first-hand look at this stuff from the coding perspective. There's lots of benefits to this. Okay, so you can do this with the UI. This doesn't give you a brand new superpower in itself. It will show you how it works in depth. So if you want to create your own application, do this. You can create smart contracts that would interact with MakerDao to create a new app that helps with this functionality. I mean, you can also do this with flash loan transactions, but you can also do this for client-side applications. So I'm going to show you the smart contract way to do it, and then also the front-end way to do it. So before we jump into that coding example, the last thing I want to answer is why would you want to mint DAI in the first place? Okay, so some people have asked that here. I saw this question pop up on Google, so actually this intrigued me, so I want to read it here. So this person's saying, as far as I can tell, everything is against you. Okay, you have to put in 100% collateral. So here's some reasons. So if you want to buy millions of DAI to put in a pool, it may be easier to mint than buying on exchanges. So some people who are whales for sure don't want to buy a lot of DAI. This may not be true, to tell you the truth, anymore because there's so much liquidity on exchanges. This is from 7 months ago. But at the time of writing this, basically you can mint DAI, which would be easier to put into liquidity pools for yield farming. Another reason is if you believe your collateral raise, you can mint DAI and use it to buy more collateral. So that's important to understand. So basically the whole idea is, let's say you're using Ether as collateral, like I showed you in here. It's called leverage. So basically, let's say you bought ETH at ETH is probably about $3,500 time for this video. It's funny if you're watching this video much later, it'll be comical to see where that price is, if it's up or down. But let's just say for easy numbers, you bought ETH at $1,000 and you're expecting it to rise in price to where it is today, like $3,500. Okay. Well, during that time, you would watch the price rise in value, and if you minted collateral with DAI, well, you could use that DAI to buy more ETH, right? And then you have greater exposure to ETH in that case. So that's what's called leverage, right? That's one reason people do it. And then the other thing is if you see the DAI price is above 1 USD, you can mint DAI and sell on exchanges. That basically be like an arbitrage opportunity here. So there's lots of reasons why I'm going to do this. Yeah, totally. So basically, people minted DAI a long time ago when ETH price was very cheap and have done quite well for themselves. So now getting into coding, okay? So I have included some coding resources down in the description below where you can download the project. Let's go ahead and open it up on our terminal and we'll get started. All right, so now let's go ahead and start coding the project. So go ahead and download the file and the resources below. Go ahead and open your terminal here, and let's go ahead and install dependencies like this, npm install. All right, so this will install all the project-based dependencies with Node.js, okay? So we do have a Truffle project here, so make sure you have Truffle installed on your computer. If this is the first time watching this program, there should be plenty of other videos that show you how to do that. If you have any questions, you can just reach out to the Slack channel. I'm sure someone will give you help installing Truffle that way. So I've got Truffle version here. Truffle is the smart contract development framework that we're going to use for this. So you can do npm install -g truffle at version 5.1.67 if you want to install this. Okay, I'm not going to do it. But yeah, let's go ahead and install dependencies. We've done that. Let's see here. So now what we want to do is start Ganache. Okay, so we want to start Ganache. Well, first of all, we're going to use a test blockchain. So we're going to use Ganache CLI. So Ganache CLI, what it does is it lets us install blockchain on our computer. Okay, so you can do this. You can do npm install -g Ganache CLI. Okay, so this will install a test blockchain on your computer. You can start it like this. So Ganache CLI. What we're going to do is actually pass in the -f flag, and what that does is allow us to actually fork the Ethereum mainnet. So what we're going to do is actually interact with the MakerDao smart contracts on the Ethereum mainnet. We're going to in a testing environment where we're not actually spending real Ether. Okay, we're going to spend test fake Ether. But that's what Ganache CLI does. It's going to allow us to point our test blockchain to a real ETH node. It's an Ethereum node in the cloud. And so we can point our blockchain to it. So we'll just say Ganache here. We'll point Ganache to this. And then we will basically talk to this ETH node. And this ETH node will talk to MakerDao. And then we'll freeze the Ethereum blockchain at a certain point in time to interact with this stuff. But we won't have to run any real money. We'll get the entire state of the Ethereum network frozen on our computer in order to do this. Okay. So Ganache CLI, we're going to fork it. And now we need a connection to Ethereum. So we're going to use Infura for this. So this Infura is an Ethereum as a service. So we don't have to run it ourselves. Basically, you can just do get started for free. Okay. Sign up. Once you sign up, you'll see your projects here. I'm going to show you mine. I normally wouldn't do this, but just don't use this API key. If you do, I'll just deactivate the app. So you want to take the mainnet Infura.io endpoint here and then do -f. Okay. And then you'll see your private keys listed here. You'll see this running. All right. So now we have a blockchain running that's connected to the mainnet. It's not really the mainnet. Again, this is a fake copy of the mainnet, but this allows us to interact with the MakerDao smart contracts without having to risk any real money. You'll see you have 10 accounts here with 100 fake Ether inside of them and the private keys for each of those. Okay. So let's go back to this. All right. So now what we want to do is let's do the contract method first. So let's open up our project in a terminal here. Okay. And you can see we have the truffle-config file or truffle.js file. This connects our project to the blockchain. So we're connecting Ganache here. We have quarter package.json file. This is where we keep our dependencies. We have a DeFi money Legos package here. This allows us to actually interact with the smart contracts and pull them into our project here. So let's go look at that. So we'll look at this mint DAI contract. So if you want to interact with MakerDao, and you want to create your own smart contract that does this and opens a MakerDao vault, then this is how you do it. So I'm using this study of DeFi money Legos library to get the Maker contracts. Basically, they've already stored the really important MakerDao contracts inside of here. So you'll see that here. We get it for free with this npm package, and then we can just call mint DAI. Okay, this contract is a custom contract that inherits from this, and then we can interact with the MakerDao contracts like this. We got our own custom vault function. So we just pass it some parameters here. These are the parameters required by the MakerDao smart contracts. We make it a payable function so we can send Ether to it. And to tell you the truth, MakerDao kind of has some funny variable names. It's I think these may be influenced by different languages in English. I'm not sure to tell you the truth. I've seen this in the past where it's kind of hard to read from other conventional programming conventions. So if it looks a little bit funny to you, it was kind of funny to me too. But anyways, so yeah, this is basically the process that you go through. So it opens the ETH ACDP. This is the collateralized debt position. That's the vault that I was saying you put Ether into. So whenever you do ETH like this, like you put ETH into the vault, okay. And you can see the ETH join happen here. So this receives the ETH amount, converts it to WETH, all right, and then adds it to that. So basically, WETH is the wrapped version of Ether. So then it locks the WETH amount into the CDP and then generates the debt. That's what this is here. And then it moves the DAI amount balance into the VAT in RAD, so the proxy's address. So it's like this. And then finally allows the adapter to access the proxy's DAI balance and then exits the DAI to the user's wallet. So this is how you send the DAI back to the user once they've minted it. All right, so these are the steps. You can actually see these spelled out in the MakerDao documentation here. So I can put a link to this on the resource down below. This is docs.makerdao.com. So if you look at the smart contract models, you can look at like the, you can basically look at guides and tutorials. So you can see like these types of things that will explain this if you want to read about it more in depth. This is a very similar type of scenario to what we're working on right now. So you can see a lot of this spelled out and use these guides as for the reference for this particular problem. Okay. So let's actually execute this. All right. So let's look at our steps for doing that. So what we're going to do is migrate the contracts. So we truffle migrate -reset just to be sure. So what it's going to do is take our contracts and actually put them on Ganache, and this will actually put them on Ganache with the current state of the Ethereum network. So we can see our migration script here. Number 2, deploy contracts, and we deploy our mint DAI contract. Okay. And then now we want to execute the script. We have 2 strategies here. One is to do it instead of a contract. So you scripts mint DAI via contract. So this is what it does. Let's run it, and I'll explain it. Oh, sorry. We actually need to do one more thing here. We need to import our address. Okay. So basically, if you look at mint DAI contracts.js, see your private key. So we're going to paste your private key first Ganache CLI account here. So you could, the better way to do this honestly would be to store this as an environment variable. I'll leave that to you as homework. So just don't take any real private keys and store them inside of here. This is for just tutorial purposes only. I'm just going to use a private key from this account. So private key is like your password, and you need the password in order to do anything on behalf of the account. And so that's what we're doing here. Getting that, putting it here, and then let's just try the script again. So the better way to do this would be to create a .env file. We've done this in lots of other tutorials in this program. I'll leave that to you as homework. Just make sure you don't commit a real private key with real money inside of it if you decide to push this project to GitHub or leave it on somebody else's computer. All right, so here you go. You see the script has executed, so we balance ETH before is 99, then we've minted DAI, and the 0 DAI balance, and then we balance after is 96, and now 5100 DAI. Great. So you can see that here. We got our contract. We logged the balances before, okay? And then we basically called our custom function here with all the variables, okay? And you can see all this stuff passed in. We're getting these default, if some of these variables look confusing, like whenever you're going to the contract here, so if you don't know what this is, you don't know what those values are supposed to be. The cool thing is the Money Legos library provides you with those settings so that you don't have to go searching for them. All right, so you choose the Money Legos library and it shows you all these values so that you don't have to go looking for them. It's really nice. Okay, so anyways, we can pass in this value here and then to the settings, and then we log the result after. Okay, so there you go, boom. So the next thing we're going to do is mint DAI via a script. Okay, so this will be without our proxy contracts. We want to do the same type of thing where we copy our private key, which is do it from the old script here. So we be able to sign transactions. So we're going to paste our private key here and do it. Let's just do a second one actually. Let's do a new account. So we want to see a fresh account, not modify the one we just used. So let's go back to the top here. Let's do the second account in the list. Okay, so zero-based index of the first account is 0, second account is 1. If you're new to programming, that's a pretty common convention. So what this does is everything in JavaScript. So we do this with Ether.js, and so what we do is create a JavaScript version of the DAI contract. We do the proxy registry. We create a new, basically doing everything that we saw inside of the contract version. We do it entirely in JavaScript. So it takes each piece of the MakerDao ecosystem, calls it one by one, all right, and then does everything inside of here. So you might do this if you don't want to add a new smart contract and put it on the network. You have to do multiple transactions this way. One benefit of doing a smart contract way is you can ensure that all this happens on the blockchain inside of one transaction rather than breaking it up into multiple transactions. So that's one thing to understand there, okay? And so we're just going to run this, and you can study this more as homework to kind of see how each of these pieces work. But let's just go and run the script here. All right, there we go. We see the balance before. So 96. Oops, I think I did the contract one again. That's not what I meant to do. So in the README here, you want to change this. So let's do mint DAI the script. Okay, so sorry, let's do that again. I realized that there's an error here in the README. So boom, there we go. So now you can see here we have 99 before 0, and then 96, and then 5100. So same outcome, okay, but different ways of doing it. So one does it with a smart contract, you can select on the smart contract. The other one does multiple transactions, each of them in JavaScript, and this is how you do it. So, that's all I got for today. Again, this is how you use MakerDao if you want more resources on how to do it. Look at docs.makerdao.io, or sorry, MakerDao.org, I believe. No, Maker.com, sorry. It's too many top-level domains to remember. But, totally, this is how you do it. This is really important information that you need to know if you want to build DeFi apps, you want to work in blockchain, DeFi is at the center of what people are doing with Ethereum. Really huge stuff here, really valuable information. So if you like this video, click the link down below for the coding resources if you haven't already, and feel free to reach out to the Slack channel if you have any questions. All right, have a great one. Thanks for watching Blockchain Mastery University. Bye.